So, friends, in the last part of the video, I was showing that this displacement theoretically can be calculated and can be matched with the displacement obtained. Because of some limitation of the recording software, I could not record more than 30 minutes, and around 5 minutes was taken away by the running. So now, what I was trying to show is removing this exterior edges if I apply, or all edges if I apply. Basically, no elements, how to say, no edges, exterior edges, featured edges. Apply. So feature edges I have applied, and now that I have seen that at the crack some slight height deformation is there. Otherwise, it's 4.7. At the crack, it is like 4.8, 1 mm, 0.1 mm more displacement is there. So basically, this is how the body is going to be deforming. Otherwise, it's more or less same, and it can be seen to an animation also. We can see. Let us see that. Uh, let us see this through an animation. But for that, we'll make the animation slow. Okay, then animation done. So as the pressure increase, it expands and deforms. Okay, so this was regarding the uh, simulation, and how to visualize the SIF is one thing, and how to use the scripting part of it. That is the second thing that I targeted uh, targeted. So to demonstrate, now that I've shown this thing, what is SIF for this model, we have to go to the folder where it was running. So it was running here in this folder, and in this we have to go to the data file, and in the data file at the end of the simulation we will see that for some three calculations are there, um, and the first one is most accurate, can be considered the most accurate. Okay, so now that I have demonstrated the SIF calculation, the second thing which we will be doing is we have done some analysis with the this thing. So suppose I want to make it into a script. So I will just paste it, and I'll rename it as say SERI script cylinder, cylinder cylinder crack, strip cylinder crack. So suppose this is the file which I want to edit. What is it asking? To specify the language so that it will look better. P Python. So now this is the file which we uh, it has not been updated properly. Okay, no, not a problem. I will make sure that it is getting updated. For that, I just need to press the save button, and once I press the save button, the journal file will be updated. This file is of no use. This is the file which got updated, and then it can be saved. Suppose SERI50 CYLINTER okay, cylinder. Okay, so now if we see everything has come. Uh, Not much things are there, but okay, this is some saving operation that I've done. That's why it is there. Uh, this saving path also not required for the purpose of running and all. So basically, I'm going to convert it into a script file. So for converting into a script file, I tried some other mechanism for scripting and all. So mm, submit. So from submit, everything else is not required as a part of the script. And I was okay. This is something. And while converting into script, I was doing some working with some other script where these things are required for me. These are the parameters which I'll be working with. So I will, without wasting much time, I will just paste it. So there is a parameter called Ri, that inner radius, and thickness, and inner radius and thickness. Say inner radius and thickness. I just to parameterize it. I have to. I have to change the. I have to just locate these values and change it. So see, this is inner radius Ri, right? So R underscore I. This is inner radius, and length is thickness Ri plus T. Ri, no, sorry, R underscore I plus T plus T. No. So Ri plus T is going to be there. So Ri, so let us make it first the language thing. We're going to make it to Python so that it look better. So we have created this and we have created a variable here. Mm, Ri is used, Ri plus T is used here, thickness based upon that. Mm, Then what else? Mm, mm, Ri has been used, zero will be used there. P, A, and C. This P, A, and C has to be used somewhere. So this is like C. So C means there is no use of C point zero, and this is A. Okay, C A. We can write something like this is crack rising. No, no. What is this? First, cylinder sizing, crack sizing. Then there are some other things like these are material property defining, metal property defining. So we'll just not do anything about it. And then after that we have rotated it here also. I think some use is there. Yes, this is the point. Ri plus T. This Ri plus T was somewhere here, which will be used here also because 1510 represent Ri plus T. Is there anything else? Mm, this doesn't matter, so we are not going to touch it. As far as I understand, it doesn't matter. The axis of rotation dimensions are need not be parameterized. This matters, so we have parameterized it. The next FEM crack coordinate system also doesn't matter. Singularity radius. This should be as small as possible to get accurate result. That's what I understand from literature. And what else? So we have used everything, almost everything. Ri, C, T, A. What else? P, pressure. These are the loads to be applied, and the loads and load stresses. So meridional stresses and load P is to be used somewhere. Um, in our model, we have used 5 megapascal, magnitude 5. So here I think is the one where we are applying pressure magnitude P. just one space, and here already -1 is already multiplied. So this meridian Mary's underscore stresses, we can directly feed here. Okay, meridian stresses we can directly feed here. So mesh size and all can also be changed, but let us keep it like this. Now we have started with some other analysis, like some other parameters were there. Now we will do the analysis for this. Okay, let us we save it. We save it in that folder, right? And in order to run it, uh, we just need to save it, save this script for running it also. Save in the trial. Okay. So I've saved it, and now what I'll do is the previous run results I will delete. Before deleting, I'll just note down 3 5. This was the um, for the cylinder that I made as a part of the initial modeling. This was the stress intensity factor. Okay, this is the one which I'm recording it before deleting everything. So I'll just delete these things which are part of the previous analysis in order to demonstrate that how to do the analysis with trial cylinder with crack script. So this is the one actual script which we have to run. It will not close. It will ask us to close, and even after closing also some files may not get deleted. Okay, everything got deleted. We are lucky. So now that we have to just go for this folder in the Python window. Yeah, trial.py. So this script name is script cylinder crack, cylinder crack, slipped cylinder crack. So acha, one more thing is there. This is still in how to rename it, JNL journal file. We have to convert it into Python file, and now it is a proper Python file which will be running for the parameters that we have used. So it's basically running, and this proof is that so many other files are getting created. After it is run, we will open the data file and we will check if the value is changed or it is the same as we have seen earlier. Uh, Now being a slightly smaller model, earlier the diameter was like radius was 1500. Now it is 1400, 1300 something. So it is expected to be a smaller model. Expected to be a smaller, slightly lesser time should be taking. So let us see how much time it is taking. 12 2 6 we have given the analysis. I'm expecting it to be over by 2:10. 4 to 5 minutes maximum it should take. Mhm. So the purpose of this video was to demonstrate the scripting skill in Abaqus and how to convert the journal file into a script and use it. In the previous video, I have demonstrated the how to use the Abaqus as a tool for making elliptical crack using the XFEM technique in a cylinder and to estimate the stress intensity factor from the software. So, how do we know that the analysis run is over? Uh, Generally, it is to be taking less time. Let us read the data file. Go to the particular folder and instead of reading, I create a copy, take it outside and paste it here and read. There it may interfere. I think uh, this is so that the lines like this has not been observed in this data file. So it seems that it is not yet solved properly when we have taken it. So we will what we will do is we'll take the line segment again. Uh, Let us take now it is 349 uh, kb. Earlier it is 348 kb. So some updation has happened. Yes, replace. So it seems now the required updation is done. Yes, that's it. The required updation is done, and we find that the value is changed. So value is changed. Some characterization is required whether we have to take averaging or whether we have to take the first one. That I am leaving it for future. But for the time being, I just demonstrated that where is the script file. So basically, there is a change, and with the change script, it is working. So that's all for today, and let's keep this video also short. If any assistance in any type of simulation is required, please let me know in the comment and give engagement to my videos. I am a amateur YouTuber, not a professional one, but when I get engagement, obviously there will be a uh, the encouragement will come automatically to create more videos. So I'm looking for that. Thank you for watching.